Hello everyone, this is Deepto. So our today's project is measuring temperature using NTC thermistor. So at first we need to know what is thermistor. So thermistor is basically a temperature measurement sensor, you can say. So it gives output in resistance. So for that purpose, at first we need to measure the resistance, then convert the resistance to the temperature, right? Okay. So, so for this measurement, we are using MyRio 1900 along with LabVIEW software, and also we are using thermistor. Okay. Okay, so this is MyRio 1900 and here's the breadboard. We connected this through the jumper wires. Okay, so here you can see the connection, the circuit. Okay, so let's just think of this part only at first. Okay, so here we used 0.1 microfarad capacitor, 10k resistance and 10 kilo ohm resistance and 10k thermistor. Okay, so this is a NTC thermistor, so we connected this. You will find the circuit diagram in the description box. Okay, so now let's get back to the lab view. So here is my LabVIEW 2019 MyRio toolkit. Okay, so at first we have to connect our MyRio. Okay, so we are using wireless. Okay, so for that we need to connect it. Okay, so you can see that MyRio embassy is already connected. Okay, so for that we need to go to NI Max and network settings. So here you can see the IP address, okay, which is 172.16.0.1. Okay, fine. Then we have to open our project temperature measurement LabVIEW project. Okay, okay. So now we have to go to the properties. Then we have to put our IP address of my RIO, which is 172.16.0.1. Okay, okay. Then we have to connect it. Okay, so as you see, there's a green light, it's connected. Okay, so now you have to open our VI, which is temperature measurement using thermistor VI. So here is the front panel. Okay, so at first let's get to the block diagram. Here is our code. Okay, so in the block diagram we have four sections. I separated it in four sections. One is collecting the analog data through MyRio. Second one is measuring the output resistance of thermistor. Third one is conversion of resistance to temperature. And the last one is logic of LED blinking followed by the temperature. Okay. So for here we are using a file. So at first we have to collect the analog data through MyRio. For that I need one analog input. So in there uh, we are using pin 3 and pin 5. Pin 5 for the voltage input and pin 3 for the voltage output or the acquired voltage. Okay. To measure the resistance, output resistance, we need to put it in a formula. Okay. So the formula is basically VD minus VT divided by VT into our known resistance, which is 10,000 ohms. Okay. Here we are using ohm, not kilo ohm. Okay. So let me show you. Okay, so is the note. Okay, for temperature measurement, we're using two formulas. First one is formula to measure the output resistance of thermistor. Okay, so the formula is as I told you, RT is equals to VD minus VT divided by VT into R0. R0 is our known resistance. VD is our input voltage. VT is our output voltage. Okay, but as I told you that this RT value you will get it in ohm because the R0 value is 10,000 ohm. We are using 10,000 ohm, okay, not 10 kilo ohm. So we are getting the value in ohm. To convert this ohm to kilo ohm, we are just dividing it with 1000. RT divided by 1000 equals to RT unit in kilo ohm. So here is RT, VD and VT are 0, as I told you. Okay, now let's get back to our block diagram. Okay, so using this formula we are converting this, we are getting the output of resistance. Okay, so after getting the resistance, here we added one meter. Okay, as you can see it in front panel, here is our RT meter and also the indicator also. And now our next step, which is conversion of resistance to temperature. As you know, for this measurement we can't measure it in resistance. Okay, so we need to convert this to temperature. So how we can convert this to temperature? Okay, now let's get back to this word. So here is the formula to convert the resistance to temperature. For NTC thermistor only, we use this formula. Okay, so the formula is basically 1 by T is equals to 1 by T0 plus 1 by B log RT by R0. Okay, so what is T, what is T0 and what is B? As you know previously that RT and R0 is output resistance and room resistance. So the T is our output temperature which we need to measure. Okay, and the T0 is the room temperature which is 298.15 Kelvin. Okay, because will get the output in Kelvin, we are taking all the inputs in Kelvin. Okay, so the room temperature in centigrade is 25 degrees centigrade approx. Okay, and here's the B. B is the thermistor material constant. Okay, which is already given, which is 4038 K. Okay, so let's get back to our VI. So here's our VI. So for that, uh, we need this RT. Okay, so we need to multiply this RT with 1000 again. As I told you that this RT is in kilo ohm, that is why we divided it from by 1000. Okay, now we need to get back it to the ohm, so we are multiplying 1000. Okay, uh, so here is our RT in ohm and here is our R0 in ohm, RT by R. Okay, and here you're using the logarithm. Okay, as you have seen already that log of RT by R0. So the first part is 1 by T0. So here is our T0 value 298.15. Okay, as you can see it here, T0 Kelvin, and 1 by X is equals to 1 by T0. Okay, so 1 by T0 plus is log of RT by R0 into Kelvin. This is B. Okay, so we can write it that this is our B. Okay, Kelvin. Okay, so okay, B into log of RT by R0. This is B into log of RT by R0. Okay, this is 1 by B into log of RT by R0. Okay, okay, so here is 1 by B into log RT by R0, and here is our 1 by T0. So according to our formula, 1 by T0 plus 1 by B log RT by R0. Okay, so here is our output in Kelvin. So here is the formula already written. So here we are using 1 by X because this is the value of 1 by T. Okay, so we need the value of T, so we have to implement this 1 by X. Okay, so here you can get the T, but the temperature in Kelvin, so you need to subtract 273 to get the temperature in centigrade. Okay, so this conversion of resistance to temperature part is done. So Now we are going to our last step, which is logic of the LED blinking followed by the temperature. Okay, so let's get back to our front panel. Okay, in our front panel, here is our output temperature. So here we can get our output temperature, this thermometer, and here is the indicator. So as per my backend coding, here three LEDs. Okay, one is for high temperature, another one is for moderate temperature, and the lowest temperature. Okay, in diagram you can see that I used three indicators, which is high, mod, and low temperature. Okay, so we used this greater or equal because so as you see that our temperature, okay, the output temperature, if the temperature is greater than or equal to 27, you can change it as per your choice. Okay, 27.01, then it will show you that it is a high temperature. And if the temperature is greater than 24.71 and less than or equal to 27, then it will show you the moderate temperature. So for that we need the AND gate. And for the last one, if the acquired temperature is less than equal to 24.7, then it show that the low temperature. For that we can customize the color in front panel. For high temperature, go to properties. Okay, you can change the color from here. For high, same for mod and low. So I used the red color for the high temperature, yellow color for the moderate temperature, and similarly green color for the low temperature. Fine. So let's go to our. So according to the temperature, this light will blink. Okay, but for another purpose, we connected these outputs to one digital output. Okay, so in digital output section, we took three pins. Okay, one is for high, which is pin 11 of our MIDIO. Another one is pin 13 for moderate, and pin 15 for low. So fine. So get back. Okay, so through this digital output, we connected three LEDs to our breadboard, as you've seen earlier. All right. So according to the temperature, same as these outputs, uh, the lights will blink for high red and for moderate yellow and for low green. Okay. So let's just run the program in and see the output in our front panel. Okay. Okay, let's go to the front panel. So here we are executing our program. Let's run it. Okay. So yeah, I'm running the program. Okay, save. I'm in progress. Hmm. So as you can see, here is our output temperature shown in the thermometer also, and also in the indicator, which is 23.9433. Okay, and you can see the green light is also blinking. So if we heat our thermistor, then you can see changing the light. Okay, so here hitting it. Okay, then our front panel you can see that the colors are changing, and also in our breadboard the colors are changing. So now it's in moderate, so it's yellow. If I, yeah, increasing here, I'm increasing the temperature. Now it's 27 7.1, so it's high. The red light is blinking. Okay. If I remove my hand, then it will go to low temperature. Okay, it's fluctuating, but yeah. So the program is running quite well. Okay, so I hope you understand the whole programming and the VI also. Okay, so I'll share the circuit diagram in my description box. Okay, fine then. Thank you. Bye bye.